Welcome to our journey through the cosmos. Today we're exploring the top 10 planets most similar to our very own Earth. These planets, discovered by powerful telescopes and ingenious scientific methods, hold the potential to harbor life or teach us more about the conditions necessary for life as we know it. Fasten your seatbelts, space travelers, as we dive deep into the cosmic ocean to explore these fascinating exoplanets. We'll be traveling light years away, examining the size, the orbit, and the potential habitability of these alien worlds. Who knows, maybe one day these planets will be the targets of future interstellar voyages, places where humanity might one day set foot. Our first stop takes us to the constellation Cygnus, some 1,400 light-years away, where we find Kepler-452b. This exoplanet, with a radius about 1.6 times that of Earth, is a super-Earth, orbiting within the habitable zone of its star, Kepler-452. Kepler-452b resides comfortably within this Goldilocks zone. This planet is older than Earth, orbiting a star similar in size and temperature to our own Sun, but older and slightly larger. While we don't yet have the technology to determine if Kepler-452b harbors an atmosphere or liquid water, its size and location make it a prime candidate for further investigation. Until then, it stands as a testament to the vastness of the cosmos and the possibility of other Earth-like worlds waiting to be discovered. Our next destination brings us much closer to home, a mere 4.24 light-years away, to the star system of Proxima Centauri. Here, orbiting the red dwarf star, Proxima Centauri, is Proxima Centauri bb, a planet at least 1.3 times the mass of Earth. What makes Proxima Centauri b so intriguing is its proximity to us. Proxima Centauri b orbits its star much closer than Earth orbits the Sun, but because Proxima Centauri is a cooler, less luminous star, the planet sits within the habitable zone. However, being so close to its star raises some challenges. Red dwarf stars are known for their powerful flares, bursts of radiation that could potentially strip away a planet's atmosphere. Despite the challenges, Proxima Centauri b remains a tantalizing target for further study. Our cosmic journey now takes us to the constellation Aquarius, approximately 40 light-years away, to the TRAPPIST-1 system. Here we find not one but three planets potentially capable of supporting life: TRAPPIST-1e, TRAPPIST-1f, and our focus for this chapter, TRAPPIST-1d. TRAPPIST-1d is slightly smaller than Earth and orbits an ultra-cool red dwarf star much smaller and cooler than our Sun. Scientists believe that it could have a surface temperature suitable for liquid water to exist, either on its surface or in subsurface oceans. While we don't yet know if TRAPPIST-1d harbors life, its potential for habitability makes it a prime candidate for further investigation. The TRAPPIST-1 system, with its multiple potentially habitable planets, offers a glimpse into the incredible diversity of planetary systems in our galaxy. Chapter 4, Kepler-186f, a super-Earth in the habitable zone. Our next stop takes us back to the constellation Cygnus, this time to a star system approximately 490 light-years away. Here, orbiting the red dwarf star, Kepler-186, we find Kepler-186f, a planet significantly larger than Earth, classifying it as a super-Earth. Kepler-186f resides within the habitable zone of its star, meaning it could potentially have liquid water on its surface. Despite the potential for extreme temperature differences between the day and night sides, Kepler-186f's size and location within the habitable zone make it an intriguing target for further study. Could life adapt to such extreme conditions? These are just some of the tantalizing questions that Kepler-186f poses. Chapter 5, LHS 1140b, a rocky super-Earth. Our search for Earth-like planets now takes us to the constellation Cetus, approximately 49 light-years away, where we find LHS 1140b, a planet orbiting the red dwarf star LHS 1140. LHS 1140b is a super-Earth, significantly larger and more massive than our planet, but what makes it particularly interesting is its composition. Scientists believe that LHS 1140b is a rocky planet, much like Earth, with a dense iron core. Despite the challenges, LHS 1140b's rocky composition and location within the habitable zone make it a fascinating target for future study. Perhaps one day we'll be able to send probes to analyze its atmosphere and search for signs of life. Chapter 6. Gliese 667 CC, a world in the habitable zone. Our cosmic voyage now takes us to the constellation Scorpius, approximately 23 light-years away, to the Gliese 667 system. This system is home to Gliese 667 CC, a planet orbiting the red dwarf star Gliese 667 C. Despite the potential for extreme temperature differences between the day and night sides, Gliese 667 CC's location within the habitable zone makes it a fascinating target for further study. Could life exist in the twilight zone between the scorching day and frigid night? Gliese 667 CC stands as a testament to the incredible diversity of planetary systems in our galaxy. Chapter 7. Our search for potentially habitable planets now takes us back to the constellation Lyra, approximately 1,200 light-years away, to the Kepler-62 system. Here, orbiting the star Kepler-62, we find Kepler-62f, a planet significantly larger than Earth, classifying it as a super-Earth. Scientists believe that this planet could be a water world completely covered in vast, deep oceans. Kepler-62f orbits its star within the habitable zone, meaning it could potentially have liquid water on its surface. Despite the potential for extreme temperature differences, Kepler-62f's potential for water and its location within the habitable zone make it a fascinating target for further study. Could life exist in the depths of its global ocean, perhaps clustered around hydrothermal vents? Kepler-62a offers a glimpse into the incredible diversity of planetary systems in our galaxy. Our next destination brings us relatively close to home, a mere 11 light-years away, to the star system of Ross 128. Here, orbiting the red dwarf star Ross 128, we find Ross 128b, a planet slightly larger than Earth. Scientists believe that this planet has a surface temperature that could be very similar to Earth's, potentially ranging from -60 to 20 degrees Celsius. This temperate climate, combined with its proximity to Earth, makes Ross 128b a prime candidate for further investigation. Despite the potential for extreme temperature differences between the day and night sides, Ross 128b's temperate climate and proximity to Earth make it a fascinating target for future study. Perhaps, one day, we'll be able to send probes to analyze its atmosphere and search for signs of life. Our cosmic journey now takes us back to the constellation Lyra, approximately 1,200 light-years away, to the Kepler-442 system. Here, orbiting the star Kepler-442, we find Kepler-442b, a planet significantly larger than Earth, classifying it as a super-Earth. Kepler-442b resides within the habitable zone of its star, meaning it could potentially have liquid water on its surface. Despite the potential for extreme temperature differences between the day and night sides, Kepler-442b's size and location within the habitable zone make it an intriguing target for further study. Could life adapt to such extreme conditions? These are just some of the tantalizing questions that Kepler-442b poses. Kepler-442b stands as a testament to the incredible diversity of planetary systems in our galaxy. Our final destination brings us to the constellation Ophiuchus, a mere 14 light-years away, to the Wolf 1061 system. Here, orbiting the red dwarf star Wolf 1061, we find Wolf 1061c, a planet over 4 times the mass of Earth. Wolf 1061c resides within the habitable zone of its star, meaning it could potentially have liquid water on its surface. Despite the potential for extreme temperature differences between the day and night sides, Wolf 1061c's location within the habitable zone makes it a fascinating target for further study. Could life exist in the twilight zone between the scorching day and frigid night? Wolf 1061c, like all the planets we've explored today, stands as a testament to the incredible diversity of planetary systems in our galaxy. Thanks for joining us on this cosmic adventure. We've journeyed across vast distances, exploring planets that orbit distant stars, each with its own unique characteristics and potential for harboring life. As we continue to peer deeper into the cosmos, we are finding more and more exoplanets, expanding our understanding of the universe and our place within it. Don't forget to like, subscribe, and hit the bell icon for more amazing space content. Until next time, keep looking up. Remember, we are all made of stardust, connected to the vast cosmos in ways we are only beginning to understand. Keep questioning, keep exploring, and keep the wonder of the cosmos alive in your heart.